Hi, welcome to this new video. My name is Sergio, I'm a computer vision consultant, developer, and course instructor, and I help companies, freelancers, students, and researchers to easily and efficiently build computer vision projects. Today we're going to see Mask RCNN and projects, very useful projects that are built with Mask RCNN to help industries either to find defects on their products or to improve the production by saving costs, like speeding up the production, because Mask RCNN is a very powerful algorithm. We see many samples on the web where people are tracked, where we see animals correctly tracked by Mask RCNN. Also, we see other samples like the cars, bicycles, and a lot of general elements. But in my opinion, and I found many researches about that, I want to find something very practical that can help industries, and we're going to see that today. So I will briefly talk about Mask RCNN and why we need to use that one instead of other algorithms, and later we will see a few project ideas that we can build with that. So let's go. Before talking in the specific about Mask RCNN, let me show you the 4 different most common type of projects that we can do with computer vision. And from this, then we will understand also why we're choosing Mask RCNN instead of other algorithms. We have the first type, which is the most simple. It's object classification, which means from an image, detecting what's inside the image with a category. So that's why simple object classification. In this image, for example, the classification will be to say just that there are dogs in this image and nothing more. After the classification, we have object detection. Object detection is much more common and of course even more useful today, because we do not only say what's inside the image, we also tell the position of the specific objects. In this case, we have 2 dogs. We don't only detect that they are dogs, but also we can detect through object detection a bounding box surround each single object. And through object detection, we can also separate them, so we know even if they are touching together, we know that these are 2 separate dogs and we have 2 different bounding boxes. And one of the most popular algorithms for this is YOLO. We have different versions of YOLO for object detection, which are commonly used nowadays. Then we have third, semantic segmentation. In semantic segmentation, we are able, it's somewhat more advanced than object detection in the sense that we do not only detect the bounding boxes, but we have the exact segment of the objects. In this case, we have the dogs detected, but we have also the boundaries of both dogs. But you might notice something. We don't have the dogs split between them because semantic segmentation doesn't separate the instances. So we know that there are dogs. This might be for semantic segmentation a huge dog, not to separate dogs. And popular algorithms for semantic segmentation are UNet, SegNet, and they are used, for example, for MRI scans, either to, in general, detect, for example, brain cell tumors, because then it's fine not to have separate segmentation. So there are many researchers which show semantic segmentation used for MRI scans. And then we have instance segmentation, which is somehow more advanced than semantic segmentation, because we do not only get the segmentation, so the exact contour boundary of the object, but also we're able to split the instances. So we know that in this case there are 2 objects, so there are of the same category, so we have 2 dogs right here. And Mask RCNN has been around for years, since 2017 when it was first launched, and it's still a very popular algorithm. I use it for many projects and I found many interesting projects built with it, and I'm going to share a few of them, plus I'm going to share with you a few ideas to build your own projects. So let's go. Let's start with the first one among the researches I found with interesting projects. This is made by students from Korea, I guess all of them. By the way, all the researches that I'm going to showing this video will be linked down below, so of course you can read them. They're free, public, available, so you can access them and you can see their author and everything that they wrote in the research. This is a segmentation model for strawberry diseases based on masked RCNN. What was their goal? Their goal, they explained that the plant diseases must be identified in the early stages for pursuing appropriate treatment procedure and reducing economy and quality losses. So this is indispensable for low cost and highly accurate approaches for diagnosing plant diseases. And they also say that there are two ways to solve this problem. Normally, one will be to manually check the crop quality, so it will be a person checking their quality, or second, by using a solution for like pesticides during the food production, but they are chemicals, so they are harming the leaves and lowering the food quality. So that's why they decided to implement this algorithm with a very good result. Somewhere they said about more than 80% of accuracy in the detection on the diseases, and they were detecting 7 specific type of disease, both on the strawberry and also on the leaves. So now I'm just scrolling to check a few of the picture where they explain more about the diseases that they have been searching, and they have been applying masked RCNN for, and also in their research they show the result. So this is all the interesting research that these students made. You can see like the leaves, that they clearly show some disease. Even to someone that is not expert about leaves, you can see that there is something wrong in these leaves right here, or this one, for example. So these leaves, they clearly have something not right. So this one of the projects, so using in general masked RCNN for the disease, so they can be leaves, they can be also different plants, different fruits, so not only the strawberries but also other products. Then we have the second research, which is about masked RCNN refitting strategy for plant counting and sizing in UAV imagery. So this is, in simple words, from a drone footage, so from a very big image of a field, detecting the plants. On these plants you can check the size of the plants, you can check their homogeneity, you can make the count of how many plants you have. And this double objective counting and sizing is achieved through the detection and segmentation of individual plants by fine-tuning an existing deep learning architecture called masked RCNN. So remote sensing allows the agricultural community to inspect large land parcels using elaborate instruments such as high-resolution visible cameras, multispectral and hyperspectral cameras, thermal instruments, or LiDAR. So these are a few of the instruments that are used to inspect the field where we have the crops. And among these instruments, then we have the algorithm masked RCNN, which is used to detect some of them. The resolution required for individual plant detection and segmentation is 1-2 centimeters per pixel, imposes a strict limitation in the operations. So you need to consider that these fields are very large. So fields may be several hundreds of hectares, which implies that acquired image will be of a particular large size. And the image can be around 0.2 gigabyte per hectare. So just one single image, 200 megabytes per hectare. So we need to work with a very large images when it's about this field. And I'm going to show you some images about their research to give you an idea of what masked RCNN can achieve. So this is just a frame from their footage of the crops, and in the crops they use lettuce and potato crops. For if I'm not wrong, later I'm going to check and make sure about that. Okay, here from the footage, we have mask RCNN, which is segmenting the crops. You see we have all the crops correctly segmented and there are separate instances. And so we can make also the count. This image right here gives you an idea of the crops correctly separated and detected. Let's see a few other images and samples that we have here. So we can have also the ground truth mask. So if we want, we can remove the background and just show the crop. So once we have the detection with the segmentation, we can do a lot. For example, here we have the center of the plants detected on this part right here. A few other details. And also you can classify somehow the crops based on their size. So you can, to also be visually clear, you can give a more clear, a more bright color to a smaller crop and darker color to bigger crops, so that with just a simple view without reading the numbers, you can have an idea about your plantation. So this, of course, will make sense to the eyes of an expert in the field. And just to confirm, yeah, the dataset are composed of high quality digitized mask of potato and lettuces on this specific sample right here. I've also been doing some similar work in the past, not using mask RCNN, but I was using simple object detection. I have a full video and article, so I'm going to put also the reference for this article in the video, which is on YouTube, where from a drone footage I was counting broccoli's plantation and also extracting the single crops, so taking snapshots of each single crop. In that case was done with object detection, just starting from samples from the drone footage. I was able to, okay, let me maybe increase the size of the image. I was able to first detect them, then track them by associating a univocal ID to each single element, and finally to count them. This one was simple object detection. So we mask RCNN, so mixing the tracking and the mask RCNN, we can have a better result because we can have also the mask. So that's very good to check the homogeneity of the crop. And this, the both project I was talking now, the first about strawberry, the second about the plantation, are both in the agricultural field. Let's now see something quite different on another field. Let's now talk about sport analysis using mask RCNN. This research was very interesting. Also, again, about this research, I'm going to put the link down below. It's made in University of Leipzig in Germany, for what I see. Utilizing mask RCNN for waterline detection in canoe sprint video analysis. On canoe sprint analysis, so for sport analysis, there are different ways to improve the performance of the athlete. One, and probably the most obvious, will be just to study the kinematic, so the movement of the joints, to make the best movement to get the best result with the lowest and minimal effort. So this, in general, in every sport, like the technique and the kinematic is one of the most important. But in canoe, there is something more also regarding the waterline. So we need to consider that the canoe works in another environment, so it's also the water is subjected to environmental changes, which can be the wind, which can be a lot of other factors that make some movement in the water. So we have the waterline detection that is necessary to check and improve also the performance of the athlete. And this research is all based regarding detecting the waterline movements by using mask RCNN. The idea was that this can be done also, of course, by experts, by researchers manually. So the manual analysis procedure of this standardized video sequences is time consuming, require expert knowledge, and it's also subjected to individual error. So that's why they wanted to move this problem and try to solve this problem with mask RCNN to a point where an expert and the algorithm would agree to the final results. So it was also important to know that that there is some method behind that. So if the expert can see that and the algorithm can see that, but much faster, much easier, then of course it's a good research and good project can be achieved through this. And you see on all the research you have some study about the mask and the segmentation of the waterline, and I found this to be a very original and interesting project which I never thought about. So I'm going to put down the link for this research below, and also this might give you ideas on how to use mask RCNN on other different fields, also talking about sports or other different sports where you need somehow to detect the ground, some movement of the ground, and so on. Let's now see another project, which is mask RCNN for automated segmentation of condensed water vapor plumes for multi-view imagery. So the title seems quite complex. This research is not fully publicly available, so if you want that, I'm going to put the link. You can get that. You should buy that somewhere. There is this public image sample from this research which makes clear the purpose, and in this case through mask RCNN we are able to see the condensed water vapor, which are this one. So we see them right here, and mask RCNN is able to detect them. So you can use this for other pipes if you want to check the size or like the smokes that comes out of the pipe in real time. Mask RCNN will definitely help you do that with a very good accuracy. These are a few of the researches that, of course, there are many more researches about mask RCNN, but also there is no research about this, but I found a few images about conveyor belts. This image specifically, I took it from a manufacturing that produces conveyor belt, but just to give you an idea that you can also use mask RCNN for different products that are passing on the conveyor, and you can check in real time the size of the product. Once you have the segmentation, also you can check if the product respects certain shapes that maybe your product needs to have. So it's somehow you can check the quality through mask RCNN. You can check the color if you have different products, and you want to have, they need to have, let's say, one specific color. If they have different color, it means that there is some damage to them, like the fish. If the fish has a different color, probably either is rotten fish or there is something wrong with it. You can do that with mask RCNN by associating different classes. So if the fish has this color, is a good fish. If it's yellow somewhere, you can say rotten fish and so on as a second class, and you will be able to identify that. Also, you could do that just on the entire fish. Also, if there, you can find inside some, if something is not wrong, for example, through mask RCNN, you can also segment the defects inside that specific product. I hope I gave you very good ideas and on how you can use mask RCNN to build projects, computer vision projects, to help the industries. I have a very simple mini course for mask RCNN where I explain how to make the training very easily for multiple products. You can find that on the pysource.com courses. Also, let me know if you have other ideas of this type of project which requires segmentation, just share with me your idea. I will be happy to discuss about that, and I might release a video if I find very good ideas. This is all for this video. See you in the next one.